Okay, today we're going to look at our third method to solve quadratic equations, and it is solving them by factoring. What you're going to see is we want to have the equation in standard form, and then if it's a fairly easy equation, factoring is a really good method. So remember, with graphing, we could have it in any form. To solve by square rooting and using algebra, we wanted vertex form. So now when we get to standard form, we're going to look at a couple different methods. So we could switch this to vertex form and then do it that way, but it's a lot faster just to use some other methods. So factoring, what we're going to do is take in our equation, make sure it's in standard form equal to 0. So once it is, we're good. And we know that basically we're just going to be reverse foiling it. So we know that if we took this thing, our two factors should look like something times something. And if we look at our first term, we have x squared for our first term, so we know we'd have to have x times x to give us x squared. And then our last number is negative 21, so we need to know what two numbers multiply to give us negative 21. So that c value of the equation, we want to figure out what two numbers have a product of 21. So let's just use 7 and 3. Right, we're going to multiply those two numbers to give us 21. So 7 and 3, so we need one of them to be negative. So we could go negative 7 and plus 3. So that multiplies to negative 21. But what we want to do then is check to see if the sum of them adds up to the middle term. So minus 7 plus 3 would give us negative 4. We want positive 4. So all that means is we've got our signs backwards. We should have had plus 7 and negative 3. So that ends up being our factors. So let's just kind of take a look at it here to see if we're actually indeed correct. So if we actually take our factors and FOIL it out, x times x is x squared, x times minus 3, 7 times x, and 7 times minus 3. So if we simplify that, we would get 4x minus 21. So you can see with foiling things out, those two middle terms add together to give us the middle of our equation. So in this case, we do match original, so that's correct. Those are our factors. So now our last step is, once you have it factored, which is pretty easy, you can usually just sort of guess and check at those numbers. The next part is, how do we get our actual solutions? So what we want to do is take our factors, and remember our factors are just a different way of writing the equation. So if we have x plus 7 and x minus 3 as our factored form, we want to solve each of those factors to be equal to 0. So our first one would be x plus 7 equal to 0, and our second factor is x minus 3 equal to 0. So to solve this, we just basically do the opposites. So minus 7 on both sides, we get x equals negative 7. This one we want to add 3 on both sides, so we get x equals 3, and those will be our two solutions. So let's try a couple more. So once again, we're going to try to sort of guess and check and think of this whole sum and products idea. Oh, this is the same equation. So let's skip this one. Let's go back to my title page one. So we have x squared plus x minus 42. So we'll use this equation, because yeah, we already knew this one was plus 7 and minus 3, so that doesn't help us too much. Okay, so let's try this new one. So x squared plus x minus 42. So once again, we know our two factors. We want to break our x squared down, so that'll be x and x. And our 42, what two numbers multiply to give us 42? So that'd be 7 and 6. And we want them to be negative 42, so one of them is going to have to be negative, but we want them to add up to be positive 1, right? Remember, there's a 1 in the middle there. So that means if we have plus 7 and minus 6, that would add up to the plus 1. So there's our two factors. So we just solve each one equal to 0. So the first one will be negative 7, and our second one will be positive 6. And there's our two answers. Okay, here's another one. So our two factors in this case will have x and x. What times what is 9? So let's try 3 and 3. Do they add up to 6? Yes, if they're both 3. So you can see we actually get two factors exactly the same. So if we make one of them equal to 0, we would get negative 3. So in this case, we actually only get one solution. So if we go back to our last one, we actually got two solutions. So if we were actually to graph this thing and solve it by graphing, we would get our two solutions. So in this case, we'd have one at negative 7 and one x-intercept at positive 6. So this next one, because we got both factors being the same, we only have one distinct answer. So that just means we're going to get a graph that has only one x-intercept. Okay, So you can see it, because it's x plus 3, we could think of it as just being x plus 3 squared. So we actually get two factors, but they're both the same, which would only give us one solution. Here's one that's similar. It looks a little bit funny because we have no middle term, but you still do it the same way. We have x and x, so we'd ask ourselves what times what is 16, but now has a sum of 0. The middle term is 0. So we'd have to have 4 and 4, and because it's negative, one will be plus, one will be minus. So those will give you a sum of 0. We call that a difference of squares, where you just basically are square rooting. And we could actually solve this question by switching it to vertex form, which is pretty easy. Bring the 16 over, square root both sides. So we'd have 4 and negative 4 as our two solutions. But if we do it by factoring, we can see we get the exact same answers either way. Okay, here's another one that looks a little bit more complicated. So the issue now becomes as if we get that number in front. So we have this 5 in front, and it's a lot easier to solve these questions without that a value. So with this one, because all the numbers are divisible by 5, we can actually common factor out that 5 first. Now, if we do our factoring, it's a lot easier. So we'd have x and x. What times what is 6? We'd have 3 and 2. We need it to be negative 1, so it'd be minus 3 and plus 2. So now our solutions are positive 3 and negative 2. The 5 out front doesn't do anything. It's just there for the ride, so you don't need to worry about that one at all. Okay, next question, same sort of thing. We got this quarter, so we can actually take out that quarter. So we'd have x squared. Here we have 1 divided by a quarter would actually be 4. We've got to be careful there. We're going backwards. 3 divided by a quarter would give us 12. So now our factors would be 4 and 3 works for 12, but that doesn't add up to 4. So we just got to try a different one. So that would be 6 and 2. 6 times 2 is negative 12. Negative 6 plus 2 would give us negative 4. The quarter out front does nothing. So our solutions are 6 and negative 2. Okay, here's another one. We try to do our factoring. We have x and x. Factors of 2 would be 1 and 2. And we run into a problem because that's the only two things that multiply to 2. And if we try to add them, they'll give us 3. They won't give us negative 4. So even if we put negatives in, that gives us negative 3. So that means they don't work. We actually have no factors. So in this case, if we actually try to graph this thing, if you put in x squared minus 4x minus 2 into your calculator, just to take a quick look at what the graph looks like. We get there we go, hit graph. And we actually get a graph in this case that goes down. So we run into a little bit of a trouble. So according to our factoring, we get no factors, which could mean that the graph just has no solutions. It could be possibly no solutions if it would look like that. But if we actually look at the graph, we actually get 2 intersection points, and they're both decimals or square root values. So what we see here is we run into a problem with solving by factoring. It works well for nice, easy whole numbers, but it doesn't work so well for decimal type ones. So we don't know those solutions other than we could solve them by graphing. So we're going to actually come back to a question like this in the next lesson. So for now, you would just say there are no factors, and that's it. Our last type now is another issue where we have a number in front, and we can't divide it by 2 without getting decimals. So in this case, we actually run into an issue. So what you want to do is sort of do the guess and check method like we were doing on the previous ones. The only thing that's different is our front number now will be, we have a 2 in front, so we're actually going to get 2x and 1x as our factors, not just x and x. And then our 5 would be 1 and 5. And then you just got to be careful of your signs. We want it to be negative 5, so one of them is going to have to be negative, and the other one's going to have to be plus. So let's just guess at that scenario. And then let's FOIL this thing out. So if we multiply the first 2, we get 2x squared. Then we'd get 10x. Then we get minus x, and then we get minus 5. So is that the same as our starting question? Not quite. That would give us 10x minus x would give us plus 9. We want minus 9. So all that means is we guessed at the wrong sign. So that should be a plus and then a minus, and that would be our two solutions. So if our two factors are 2x plus 1 and x minus 5, what we need to do now is solve each of these to be 0. So you got to be a little bit careful. It's not always just going to be the opposite. Like when we do x minus 5, that one gives us positive 5. So that one's easy. But when you get this 2x plus 1, we'd actually have to bring the 1 to the other side and then divide by 2. So we actually get a fraction. We get negative a half. So factoring works okay for these kind of questions, but it's obviously a little bit more difficult. You got that extra number to worry about, but it will still work. And that's it for factoring. So when we're dealing with factoring questions, basically what you want to do is make sure they're in standard form. The factoring gives exact answers, and it's quite fast. When you get easy numbers, the sum and products are actually pretty easy to figure out. So that's the pros. The cons, doesn't work so good for complex ones when we have that number in front, and we also saw with that one that there were solutions, but we couldn't get them by factoring. So it doesn't work when we get difficult decimal square root type answers. That's the method we're going to look at in the next lesson, is how to deal with those tougher ones. And that's all.